Okay, hi everyone. I'm going to work through the topic 14 additional problems, part one, and I hope that this will help you get ready for the quiz on Friday. I did post a sheet of formulas that you need for the quiz on Friday. I will be also providing those formulas on Friday, so I think it would be in your best interest. No quiero decir eso. Okay. Hi, everyone. Today I'm going to be working through topic 14, part one, additional problems. All right. So let me go ahead and let's look at those problems and get started on them. So you should be able to see um, the list of additional problems. So the first one is to find the simple interest on a $500 investment made for 2 years at an interest rate of 8% a year. And we're asked to find what is the accumulated amount. So let's go ahead and try that one. This is the first problem. Okay, so since we're asked for simple interest, we know the formula that we're going to need is the simple interest formula. Now remember, because simple interest is a line, remember we talked about it being a line, you are always going to have the time um, variable that is going to not be an exponent. So when it says simple interest, we don't have an exponent. Okay, we are told that the principal is $500, and we're told that the rate is 8%, and we're told, which we know we have to convert to a decimal, so that's 0.08, and we're told that the time for the investment is 2 years. So we're just going to plug all these values into this formula, and we're going to get that A is 500 times 1 plus zero point zero 0.08 times 2. Okay, so that's fairly straightforward. Now, one of the things that we noticed was that I was helping a student and I noticed that you have to be really careful when the problem says what is the accumulated amount or what is the total interest earned. So if it says just what is the total, that's the accumulated amount. But if it says what is the total interest earned, that's just the interest. And remember, the interest part is just um, it's the distribution of the principal to R and T, so the interest is just PRT. Okay, so that is a different question than what was asked in number one. Number one was asked for the amount accumulated after 2 years. So we're going to put that in. So it's one. So sorry, I'm going to start here with the 0.08 times 2, and I'm going to add 1 to it, and then I'm going to multiply that by the 500, and I get 580. Okay. The second problem was find the accumulated amount at the end of 9 months. So our time is 9 months, and I'm going to convert that to years. Uh, so it's asking to find A. So we know we need to find A on an $800 deposit. So we have an $800 principal in a bank paying simple interest. So we're going to use a simple interest formula at a rate of 6% a year. Okay. So all I did was read that problem and write down each of the things. So we have time was 9 months, and we can't just plug 9 months in because what's really important to remember is that the time in our simple interest formula, and anytime you see a T, all these T's in these formulas are in years. Okay, so you have to use years. So let's talk about that. We already talked about how to convert a percent to a decimal. Now we also need to talk about how to convert something that's given in some alternative units besides years when it's talking about time. Okay, but otherwise we know the principal was 800 and the rate was 6%, and we want to find A. So we're going to use that same formula we had used in 1, but the only difference is that T has to be converted to years. So it's 9 months. So we're going to say 9 months divided by 12 months is equal to, and the reason why this converts to years, if you want to kind of be ultra detail oriented here, is because we're actually going to multiply by a disguised form of 1 that says that 12 months is 1 year, and we can perform algebra on the units, and what we end up with is that the months are going to cancel. Right, this is a disguised form of 1. 12 months is 1 year, so I'm just multiplying by 1, but in the end, my units are years per year. Okay, so I end up just getting I hope I can edit this. All right, if I can't edit it, so just forget what I just did there because I think it's just going to confuse everyone. I'm going to erase that. Let's just say, let's just keep this simple and just say, okay, this is 9 months out of 12 months. All right, which is the same thing as 3/4 or 0.75. Okay, so it's 3/4 of a year. All right, so let's get that amount, and we're going to go with 800 times 1 plus the rate, which is 0.06, right? And we're going to multiply it by 0.75. So I'm just putting extra parentheses for emphasis here. So let's go ahead and calculate that. So we're going to have zero point 0.06 times 0.75, and then we're going to add 1 to it, and then we're going to multiply that whole thing by 800. And I get 11,000, sorry, 1100, 1,160. Okay, so let's go on to part number 3, which says, and I'm going to be reading this, and at the same time, I'm writing what I'm reading. So a bank deposit pays paying simple interest grew from an initial amount. So we're told that it grew from an initial amount of $1,000 to a sum of $1,075. So the amount at the end was 1,075 in 9 months. So again, our time is given as 9 months, and we know that has to be converted to years. So 9 months out of 12 years, we just did it in problem number 2, and we know that that's 0.75 or 75% of a year, 3/4 of a year. We want to find the interest rate. So in this problem, we're told to find R. All right, so it's a little different than the last problem. We're going to still use our simple interest formula. So A equals P times 1 plus RT. But we know everything in here except for the R. So let's put in 1075 is equal to 1,000 times the quantity 1 plus the rate, which we don't know, and then time 0.75. Right? So you can divide both sides by 1,000. And we'll see that we get 1075 divided by 1,000 is 1.075. All right. And on this side, the 1,000 cancels out, right? That's the whole reason we divided by 1,000. And we're left with 1 plus r to the point multiplied by, oops, I wrote that wrong, multiplied by 0.75. Right. So that now we're going to subtract 1 from both sides. And we're left with 0.075 is equal to 0.75 times r. Sorry about the ringing. All right. So we're going to divide by 0.75 and 0.75. Okay. And so over here, these are going to cancel, leaving us with r. And then the rate is going to be this 0.075 divided by 0.75, right? And that's going to equal 0.1. So the rate is 0.1 written as a percentage is 10%. Okay, so that takes care of those first three problems. Let's go on and do the next ones. So let's see what the next one is. All right. Um, okay. For for problems 4 to 7, we want to find the accumulated amount A if the principal P is invested at the nominal interest rate R for T years. All right, so all of these problems seem to be straightforward. We have different principles, we have different rates, we have different amount of times, and we have different um, conversion periods, right? So we're just going to go ahead and solve these. So let me erase the whiteboard here and let's crank through these and see how, just to make sure we're all good and solid on doing these calculations. All right. So number 4, principal is 2,500. The rate is 7%, which we're going to convert to 0.07. The time is 10 years and it's compounded semi-annually. So let's go ahead and write how many conversion periods semi-annually is. M equals 2. All right. So for all of these problems, we're going to need to use our compound interest formula. So remember our compound interest formula. So for all these problems, I'll write it up top, is A, the accumulated amount is the principal we start with, times 1, the quantity 1 plus I raised to the n, where I, remember, is the nominal or annual interest rate divided by the number of conversion periods, or the M, and our N is the number of total conversion periods that we are going to be accumulating interest over. So that's going to be the number per year times the number of years, or M times T. Okay, so what we need to do is go ahead and plug into this formula. So our amount is going to be, actually, before we do the amount, let's calculate the I and the N. So the first thing to do is to calculate the I. Remember, the I is the annual rate divided by the number of conversion periods. So our rate here is 0.07 divided by 2. Okay, and that's 0.035. And then our N, or the number of times we're going to be applying this conversion formula, is just our number per year times the number of years. And so that's 2 times 10, or 20. Now we have everything we need to plug it directly into this formula for the compound interest. So we're going to do 2,500 times 1 plus 0.035 raised to the 20th. Okay, so let's make sure you can get that on your calculator. The way I do it is I start inside the parentheses. So I do 1 plus 0.035, and then I hit equal. So I get 1.035. And then I hit the little button that has a x raised to a y. Now, if you have a TI graphing calculator, it's really nice and easy because you have all the parentheses and you can just type the whole thing in and see what you're doing. So that's actually a much better calculator than what I'm dealing with. But so you should be error proof, whereas I have to be a little careful. I did find my graphing calculator had corroded. That was my issue. Okay, so the battery's corroded. All right, so we get out of this 4,974 and 47 cents. Okay, okay, number 5. Let's remind ourselves what number 5 said. So here we're going to have the principal is $12,000 and the rate is 8%, which we're going to write as 0.08. And here time is 10 and a half years. So instead of writing 10 with the half the way they did, I'm going to just write it as 10.5. It doesn't really matter. And it's compounded quarterly. So M is equal to 4, right? Compounded quarterly means we're going to apply this calculation 4 times during a year. So that leaves us with needing to figure out I, which is 0.08 divided by 4 equals 0.02. And our number of conversion periods is 4 per year times 10.5. All right, so that comes out to, so 4 times 10.5 is 42. All right, so the amount that we're going to have after 10 and a half years is going to be the initial 12,000 and then 1 plus I, our I is 0.02 raised to the 42nd power. Okay, and what I get for that is the 1.02 raised to the 42nd power, and I got to multiply that by the 12,000. So I get 27,566. So this can be a dollar amount and 93 cents. Okay, number 6. Maybe I should go ahead and put some blue squares around the answers. All right. And I apologize for the glare off my computer. I don't know what to do. Okay. And also, I realized I was still sharing the actual problems themselves. So sorry if that was really small. Let me just quickly go over it. So we, first of all, just wrote down the information that we had in the problem. Then I calculate the I, remember, which is the rate or 0.08 divided by the number of times we're compounding 4, I get 0.02. N is M times T, so 4 times 10.5 or 42. I apply this formula to get the accumulated amount. So it's 12,000 times the quantity 1 plus 0.02, which is my I, raised to the N, which is the 42. And in the calculator, I ended up with this. Okay, so now let's go back and look at what problem number 6 was. So problem number 6 tells us that the principal is 150,000 this time. And the rate is 14% or 0.14. The time is 4 years. And the compounding is done monthly. So that tells me that the M is equal to 12. All right. So let's go ahead and proceed with this. So the first thing we're going to need is the I again. So we always need the I The simple interest for that conversion period is what this is. So it's the 0.14 and it's going to be divided by 12. All right. And if we put that in our calculators, I get um, 0.01167. So you can leave it as 0.14 divided by 12 and round at the very end. I'm just showing you what I got for this. And then the n is going to be the m times t, right? So 12 times 4 or 48. So let's get that amount now. Our amount is going to be that initial principal of 150,000 multiplied by 1 plus I, which is this 0.14 divided by 12, raised to the 48. All right, so let's go ahead and do that calculation. And I get 261,751. So 261,751 and 4 cents. Okay. Problem number 7. So here we have a principal of 200,000, a rate of 8% or 0.08, a time of 4 years, and compounded daily. So remember, compounded daily gives us 365 conversion periods in that year. Okay, so now let's go ahead and work on this problem. So what we know is that the I, which is the rate divided by the M, right, is 0.08 divided by 365. And the N, which is the other thing we always need to calculate, is our M times T. So it's 365 times 4. And I'm going to do that one in my calculator. I get 1,460. So for this one, our amount after these 4 years is 200,000 times 1 plus this 0.08 divided by 365. All of this raised to the 1460 exponent. So how much do we get out of this? All right, well, let's find out. 0.08 divided by 365 plus 1 raised to the 1460. And then multiply that by 200,000. And I get 275,415 and 80, well, actually, if you round up, 90 cents. Okay. So now let's go ahead and do the rest of the problems. Now we're going to move more into the word problems themselves. Okay. So we have question number 8, financing a college education. The parents of a child have come into a large inheritance and they wish to establish a trust fund for her college education. They estimate that they will need $100,000 in 13 years from now into the future. How much should they set aside in the trust now if they can invest the money at 8.5% compounded? And we're giving some options annually, semi annually, or quarterly. So we're going to continue. Um, I'm going to keep this formula up here, but I just want to be really clear that we are actually using this formula to solve for the P. So let me erase this and actually switch over. Actually, before I switch over, let's write down all this information for problem number 8. All right, so problem number 8. We have that the amount needed is going to be $100,000, and that the child, I don't know how old the child must be, like 13 minus 5 years old maybe, right? So we're going to say 13 years from now. So the elapsed time is going to be 13, and the rate is 8.5. So the rate is 0.085, right? So 8.5% is 0.085. Okay. Now we're going to go ahead and talk about how to solve this for the present value, right? So remember, the present value formula was we just solve this for p. We divide both sides by 1 plus I raised to the n, and we end up with the formula. You can quickly arrive at this formula by just doing some quick calculations and applying the exponent rules. All right. So, and also it will be on the formula sheet. So this is going to be for compounding, um, con- compound interest, not continuous, but when you have certain conversion periods. Okay. So for this problem, we are asked, the first one was annually. So let's go. I'm going to do a little A here to save space. So when we talk about compounding annually, right, what do we know? Well, we know that M equals 1. So our I is just simply R divided by 1, which is just the 0.085. And our number of times we compound is just 1 times T, right? And our T is 13. So this is just 13. So the amount or the principal, so let me put maybe a green box around this. This is the principal or the amount that they would want to invest now so that in 13 years from now, they're able to have $100,000. So if they find this kind of a trust fund, the amount that they would set aside out of this large sum of inheritance. So, they're trying to think about their daughter, but they're also probably thinking like, well, if we did get a large sum of inheritance, how much do we need to save for her college, and how much can we use for other things? Right. So the principal is 100,000 times this 1 plus 0.085 raised to the negative 13. Okay. Now, you can go ahead and save yourself the hassle of converting the exponent to a positive and just go ahead and put this in your calculator directly. So let's go ahead and do that. So we're going to have the 1.085. We're going to raise it to the negative 13th power. So for me, on my calculator, if you have a TI, you can still do this. You're going to raise it. And when you put in that exponent, 13, you find that little plus minus button that makes it a negative. Okay. And then once you hit equals, or if you have a TI, you can just say multiplied by 100,000. And so it's showing me that the amount they need to put in for the principal is $34,626.88. And that's for part A. Okay, so let's go ahead and do part B now. So for part B, we're talking about semi-annually. So the only thing that changes for part B is that the M is now with 2, which is going to mean our I, which is our rate divided by M, is 0.085 divided by 2. Which is equal to 0.0425. Five. Should be doing these in my head. Okay. And then the n is going to be 2 times 13, right? So it's m times t, or 26. So the present value needed to have a future value of 100,000 is multiplied by this 1 plus 0 point, the 1 plus the I, right? So I'm looking here, 1 plus the I, 0425, and we're going to be raising that to the negative 26. So I get for that, so let me put that in blue again. I get 33,886 and 16 cents. Right. So now part C is that we're going to do the same problem again quarterly. So quarterly, m is equal to 4. So I equals r over m. So 0.085 divided by 4. So let's see what that is. And I get that comes out to 0.02125. And then the n is going to be the m times t, remember? So it's 4 times 13, okay, which is going to be 52, right? Okay, I'm just double checking. Yep. Okay, so now let's get our principal for this account. It's going to be 100,000 times 1 plus 0.02125 raised to the negative 52. Right, so and I get that this comes out to 33,506 and 76 cents. Okay, so that was problem 8. Let's go on to problem 9, which reads, Anthony invested a sum of money 5 years ago in a savings account that has since paid interest at the rate of 8% a year. So, and it was compounded quarterly. His investment is now worth, so it's telling us the accumulated amount. How much did he originally invest? So once again, they're trying to get us to solve for the principal. So let's go ahead and put everything we know in. It's going to be a similar type problem to what we did in number 8. Numbers are a little different. So he invested a sum of money 5 years ago. So our T equals 5, in a savings account that has paid interest at a rate of 8% a year. So R is 0.08, and compounded quarterly. So our M equals 4. And his investment is now worth, so our A, or accumulated amount, is $22,289.22. All right, so let's go ahead and plug that in. So our principal that was invested originally is just this amount, right, times 1 plus I to the negative n. So it's going to be 22,289.22 times 1 plus, we need to do the I. So that's the 0.08 divided by the 4. I'm just doing it on the fly. And then the N is the M times T, right? The number of conversion periods over the amount of time. So for us, it's 4 times 5 or 20. So our amount up here is negative N or negative 20. So what I'm getting for number 9 for the principal is, all right, well, unless there's a rounding error, I'm getting $15,000 and 1 cent. So I think that whoever originally did this must have rounded at some point. So if you take the point oh 0.08, let me just check where the rounding might be coming in. Well, point oh 0.08 divided by 4 should not be yeah, that's just point oh 0.02. So we add 1 to that, we get 1.02 raised to the 20, negative 20, multiplied by 22289. I just want to make sure that I did plug everything in right. Yep, $15,000 and 1 cent. Okay, let's move on to number 10 now. Let's read what that says. Pension funds. Okay, the manager of a pension fund, and I'm going to have to erase over here, but let's read about what we're asked to do first. Um, the managers of a pension fund have invested $1.5 million in U.S. government certificates of deposit that pay at a rate of 5.5% per year, compounded semi-annually over a period of 10 years. At the end of this period, how much will the investment be worth? Right. Well, that is a fairly straightforward compound interest formula. So we're just going to keep the formula we have at the very top. Let me erase all this and write this out. So notice that I read them twice. That's not a bad idea. The first time you get an idea of where you're going, and then you read it again to make sure you get all the math out of it. Okay, so what we're going to need is that the managers invested $1.5 million. So that's our principal. So it's $1.5 million. And the interest rate that they're getting is 5.5 per year. So rate equals 5.5% is 0.055. And it is compounded semi-annually. So that means twice a year. So M equals 2. And the time period is 10 years. All right. So at the end of this period, how much will the investment be worth? Well, this is going to be our compound interest formula right here. So let's get our I, which is our rate divided by our conversion periods, R divided by M, or 0.055 divided by 2. And I think that will come out to a nice number. Maybe not. 0.055 divided by 2. So, yep, 0.0275. And our N, which is our M times T, is 2 times 10, or 20 again. All right, so now let's just get that amount. It's going to be the 1.5 million times 1 plus I, so that's 0.0275 raised to the 20th. All right, now notice I'm able to keep this as 1.5 million because it's the only place that money's coming in. This is a rate, right? An interest rate, and the exponent is the number of conversion periods. So this is going to be a factor that gets multiplied by 1.5 million. So it's okay to just write 1.5. All right. So 1.0275, and that whole thing raised to the 20th. And we're going to multiply that by $1.5 million. dollars, and we end up with 2.58, and it's okay to keep this at two decimals, million dollars. So we put a big M. So they're going to get around $2.58 million dollars out of this. And there's more numbers there, and you could actually get really, really precise and go all the way out to the penny if you want. Let's see, to the penny, 2,580,642 and 64 cents. There we go. All right. So there you go. That's the end of the additional problems. Oh, juice. I apologize. I just realized I had that on the little tiny screen. So let me go over that real quick. So all I did was take the information they gave us. I calculated the I, R divided by M. So 0.055 divided by 2. Then I took and I got the number N, which is the M times T, and I got the 20. And then I plugged into the compound interest formula and got 2.58 million. And then I actually looked on my calculator and went, I took the decimal out 6 to the right so that I could get the full amount exactly. And then I added the pennies, which is 2 places after the decimal. All righty. I guess I need a dollar sign on that. All right. I will now be doing the additional problems for part 2 of topic 14 and also for topic 15. So stay tuned for that video.